Hello everyone, welcome back to my channel. Today I'll be discussing about what are IP addresses. So talking and connecting. An IP address is a way for devices on an internal network and external network. So an internal network, for people who don't know, is your home network. It's internal, you control it, and external networks are things you don't control. So these are managed by other companies or organizations that go beyond your home router. And IP addresses are used to communicate to these networks. Devices such as computers and smartphones all need a way for them to be uniquely identifiable on a network to communicate. So you kind of think of it as a group of people, and they're all talking to each other, and the way they talk and address each other is by their surname or their preferred name, and that's how they're able to identify and communicate to each other. And this is similar to devices on a network. They use IP addresses, which are a dotted decimal number, to identify each other and communicate. So this is how an IPv4 address looks. I'll explain what the v4 means, and just to clarify, IP actually stands for Internet Protocol. Now, IPv4 addresses are formatted in 32-bit numbers. So there's 32 binary ones and zeros. As you can see in the image below, there is, if you count, there's 32 ones and zeros. That equals to 32 bits. So one binary equals 1 bit. 8 binary of ones and zeros equals 1 bit, or 1 byte, I should say. And an IP address is separated into 4 octets, and each decimal denotes 1 octet. So 172 dot is a decimal or an octet. 169 dot is octet 2, 7 dot is octet 3, and then the last one is octet 4 or 102. So this is what I want to explain. So IPv4 versus IP version 6. So IP version 4 has a size limit of 4.3 billion addresses. So this is a big problem because at the moment there's 8 billion people on Earth. Thus, not everyone can be assigned an IP address. So this is where IPv6 comes into play. IPv6 is a successor to IPv4 and has more than 1 decillion addresses. This is more than enough addresses for people to have multiple devices on the internet and have their own IP address. And it's also much more efficient than IPv4 with more efficient headers and more efficient protocols, such as not having the need to use DHCP, unlike IPv4. Public IP versus private IP. So this is another key distinction I want people to know. Public IP addresses are routable. However, they are not free. They can be used to communicate to external networks like the internet. So for example, when you're at your house, if you want to communicate to the internet, you would need a public IP, and this is commonly allocated by IANA, Internet Assigned Numbers Association, and these people give your ISP the public IP addresses they need, which then gets handed to you by depending on the plans from your internet service provider. Private IP addresses, on the other hand, are not routable, but they are completely free. So when you go onto your computer and type in ipconfig if you're on a Windows machine, or ifconfig if you're on Linux or Mac, then you would see that you have a private IP address, and commonly it starts with something like 192.168 and then whatever number that's leading after that. But they're not routable and can only be used to talk internally to devices on your network, not to external networks such as the internet. So IPv6 address format. So this is what an IPv6 address looks like. As you can see, it has a lot of numbers and it can be a bit confusing. In another video, I will talk more into detail about what an IP, how we can make a short form of this address. But for now, I just want to give a look on how the IPv6 address is formatted, and it's formatted in a hexadecimal notation and is separated by colons. And another concept I want to talk about is NAT, Network Address Translation. So NAT allows devices on the internal network using private IP addresses. So remember, I said private IP addresses are not routable. Now, this begs the question, how do we access the internet? Well, this is where network address translations comes into play. So NAT allows allows the private IPs on your network to communicate to the internet by using one public IP. So the router translates a private IP address to a public one when outgoing traffic is sent to the internet. So as you can see in the image I have drawn here, the PC named 192.168.1.10, so it has an IP address of that. It wants to send outgoing traffic to the internet, while the router talks on behalf of the PC with an assigned public IP of 195.1.10.11, as you can see right here. This is the router's public IP, and it will translate this private IP into a public one, and then when data from the internet is coming back, it will translate it back into a private IP. So this process basically allows multiple devices on your network to all share one public IP. And this is really important because at the moment we are running on IP version 4, which has a limited address space of 4.3 billion, and we have completely run out. So this helps us conserve the limited IPv4 addresses we have in the world. So to do a quick recap on what we learned. So we learned about the difference between public and private IPs. Public IP addresses are unique. Each public IP address is unique in the entire internet, which means no two devices on the internet can have the same public IP address at the same time. And they also have routability capabilities. So public IP addresses are routable on the global internet. This means that they can be reached from any other point on the internet, assuming no firewalls or other types of access controls are blocking the connection. They're allocated by the Internet Assigned Numbers Authority. I, by mistake, said association early on, but short form for IANA, which is a company that assigns these public IPs, and are managed by regional internet registries, which distribute them to internet service providers and other entities. They also have a cost since public IP addresses are finite in resources, and they often come with a cost, especially for static public IP addresses, which remain constant over time. I'll explain what static public IPs are in a moment. And basically, these public IPs, as we know, are used to route traffic to the internet, and private IPs are used to communicate on a local area network. Devices on the local area network need their own unique private IP address so they can communicate to each other in the internal network. But these addresses are not routable on the internet, meaning they cannot be reached from outside their local network, which adds a layer of security in essence. And private IP address can be used by anyone, regardless of the organization, the company, or the ISP. Anyone can have a public or a private IP address, regardless of who they are. And there's no cost associated with a private IP address. And then we also discussed about NAT. NAT basically translates the private IPs to public IPs. So let's take that smartphone, for example, that has a private IP of 192.168.1.10. When it sends outgoing traffic to the internet, your router will translate that private IP into a public IP, and then when it receives traffic back, it will translate that public IP into private IP. And that's what NAT allows us to do. And then here's the key distinction between dynamic versus static IP addresses. Static IP addresses do not change. These are good if you're hosting a server, however, they are more expensive. So if you're hosting a server like a web server or a file server, you probably don't want the IP address of that to constantly change. So you would have to ask your internet service provider or your organization to allocate you a static IP address, but there may be additional fees associated with this. Dynamic IP addresses are commonly used in homes. They're changing whenever your router is unplugged or restarted. So let's say you have a public IP of maybe 185.50, blah, 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 right? When you unplug your router, you may get another public IP of something like 189.53, and that would be your new public IP address. But this can vary due to internet service provider policies, so always call and make sure that their policies are matching the ones we learned today. So to summarize, IP addresses are numerical labels assigned to devices on a network that use the Internet Protocol for communication. The two versions in use are IPv4 or IP version 4 with 32-bit addresses like 192.168.1.1 and IPv6 with 128-bit addresses offering a vastly larger address space. Addresses are either static, fixed, for long-term assignment, or dynamic, changing periodically and assigned by a DHCP server. Public IP addresses are unique across the internet and necessary for online communication, while private IP addresses are used within local networks and not directly accessible from the internet, relying on network address translation for internet connectivity. The transition to IPv6 from IPv4 is driven by the need for more addresses due to the proliferation of internet-connected devices. And that is my presentation for today. I hope you guys learned something new, and I will see you next time.